In the distant future, the universe will reach a stage unlike anything we experience today. Stars will slowly burn out, galaxies will drift apart, and the cosmos will fade into darkness. Yet, even as the universe grows colder and emptier, there will be a final glimmer of light, a last illumination that will shine across the emptiness, before disappearing forever. This is the story of the universe's final light. Stars are born when gas clouds collapse under gravity, igniting nuclear fusion. They shine for millions to trillions of years, providing warmth and energy. Over time, the raw material for star formation will dwindle. Eventually, even the smallest stars will exhaust their fuel, leaving behind cold remnants that no longer emit light. Red dwarf stars, the tiniest and longest-lasting stars, will survive the longest. Some can burn steadily for trillions of years, far longer than our sun's lifetime. For eons, these stars will flicker faintly, casting the last glow in a universe that has otherwise gone dark. Their light will be the final beacon for any observers who remain. White dwarfs, the remnants of medium-sized stars, will continue to shine for incredibly long periods. Their glow, dim and faint, will slowly cool over trillions of years. These ancient embers will represent some of the last sources of light, fading gradually as time marches on toward the ultimate end. Eventually, even the red dwarfs and white dwarfs will burn out. The last nuclear fusion reactions will cease, and these stars will cool into black dwarfs. These dark objects no longer emit light or heat. When this occurs, the universe will be left with no natural sources of illumination. Black holes will remain, but they do not shine visibly. They trap light instead of producing it. Over unimaginable stretches of time, even black holes will slowly evaporate through Hawking radiation, a faint emission that is almost invisible. Once the last black hole disappears, the universe will be completely devoid of light. The final photons emitted by dying stars and black holes will travel endlessly across space, without new sources of light forming. These photons will eventually redshift to wavelengths so long that they become undetectable. This marks the true moment when the last light fades completely. Galaxies themselves will dissolve. Stars ejected from their orbits and scattered across the void will no longer form cohesive structures. Even the remnants of stellar clusters will slowly disperse, leaving isolated stars or remnants drifting through empty, dark space. Planets orbiting these dying stars will become frozen, lifeless rocks. The last traces of reflected light from stellar bodies will disappear. Without illumination, planets will become indistinguishable from the surrounding void, contributing to a universe that has grown profoundly silent and cold. The cosmic microwave background, the faint afterglow of the Big Bang, will continue to exist but will be stretched into near-invisible wavelengths. This ancient light is the universe's earliest memory, but even it will fade to undetectable levels as expansion continues over incomprehensible eons. Without light, no chemical reactions can take place on planetary surfaces, and no energy can drive processes in space. The universe will reach thermal equilibrium, where energy is uniformly distributed and no useful work is possible. This is the heat death, where motion and illumination cease entirely. From the perspective of any future observer, the cosmos will be a pitch-black expanse. Stars, galaxies, and energetic phenomena that once dominated the sky will have vanished. Only the faintest remnants of photons traveling across the void will remain, slowly redshifting into oblivion. Even cosmic radiation will dwindle. Gamma rays, X-rays, and visible light from any surviving sources will eventually be absorbed or stretched into undetectable wavelengths. The universe will reach a state of near-absolute darkness, an emptiness so complete it defies imagination. The final light is symbolic of the universe's history. For trillions of years, energy has radiated from countless stars, illuminating planets and galaxies. This last light marks the conclusion of that long cosmic story, a closing chapter in a universe that once shimmered with brilliance. After the last photons vanish, the universe will enter a truly dark era. Matter will continue to drift, but no star, no explosion, no radiation will break the blackness. The cosmos will exist in a silent equilibrium, empty, cold, and devoid of any visible energy. The last light that will ever shine is both an ending and a testament. It reminds us that even in a universe destined for darkness, there was brilliance, energy, and motion. Once it disappears, the universe will be left in eternal silence, a cold, dark expanse stretching endlessly into infinity.